All right, so for on the quiz, you're going to have to build a Taylor polynomial 3 different ways. Once by the definition, the second time by definition by the known polynomials, the third one by using a geometric. Sorry, I was trying to change my pencil size. All right, so looking at this first one, we have a known polynomial mixed in there. We know what sine x is, so we'll write that polynomial down. They ask for the first 3 non-zero terms and then the general term. The general term means that you're going to have n's in it. So sine x we know is our odds, so x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And then the general term would be negative 1 to the n, x to the 2n plus 1 over 2n plus 1, because that forces it to be odd. Now the only thing I need to do is in each one of these, instead of x, I'm going to write x squared. So this needs to be x squared. Right here would be x squared cubed. X squared to the 5th. X squared to the 2n plus 1. So when you do powers to powers, you multiply them. So this sine x squared is going to be approximately x squared minus x squared cubed, which is x to the 6th, x squared to the 5th, which is x to the 10th, and then our general term, it would be x squared to the 2n plus 1. When you multiply those, you'll get 4n plus 2. And then all of this over 2n plus 1 factorial. So that will be your first 3 terms and the general term. The next one they asked for was e to the x, and you'll have 1 of each. I just happened to pick 2 of each just so you could practice. So this one starts with e to the x. So everybody comes and everybody's positive. And if I'm going to plug in 3x, that means everywhere there's an x, I'm now going to put in 3x. So I'm going to 3x here. Then we'll have 3x quantity squared, 3x to the nth power. And then we go through, and this would be e to the x is equal, e to the 3x is equal to 1 plus 3x. And you could write this as 3x quantity squared over 2 factorial. And then this one would be 3x to the n over n factorial. Now you don't have to do this on the quiz, but eventually we'll want to simplify all these. So here we would prefer to see this as 3 squared x squared over 2 factorial. So you want the x to be to its own power with nobody kind of hanging out with him. And then down here it'd be 3 to the n x to the n over n factorial. And just like we talked about in class, make sure you see consistencies. I see 3 go up each time. I see the power of x go up each time. The power is the same as the factorial. They should be very consistent. All right, the second type of build is the geometric build. So remember, the geometric looks like a over 1 minus r. It's very important that this first term is 1. If not, you need to multiply or divide to make it 1. So we see that a is x, and then our r is 3x. And if you remember what geometric is, it starts with a, and then each time you multiply by the common ratio. So you multiply by 3x. So the next one's going to be 3x squared. And same thing, we're going to multiply by 3x again. So now you'll have 3 squared x cubed. And you can see the pattern. And let's see, here would be 3 to the n, x to the n plus 1. Noticing we want to start with n equals 0. So if n is equal to 0, this would be 3 to the 0, x to the 0 plus 1, and that does give us the x back. So that's your geometric build. Now, some people have a difficult time going ahead and trying to figure out the general term, and that's okay. So another way we can do it, this general term right here for a geometric looks like a r to the n. We already have a and r. A is the first term, and then we have 3x to the n. And for the quiz, that's perfectly fine, but eventually we'll want to simplify these. So this would be x times 3 to the n, x to the n. And you see these are the same base, so we can add the powers, and it would be 3 to the n, x to the n plus 1, which is exactly what we got by guessing and checking. Okay, this one over here is also geometric. So looking at it, remember we want it to look like a over 1 minus r. This right here is not 1, so I'm going to multiply the top and the bottom by 1/3. So on the top we're going to have 3, and then 1 plus x squared over 3. So now looking at that, we are in the geometric situation, and we do have a being having the 1 plus r. So here a is equal to 3. Your common ratio is negative x squared over 3, because remember this has to be a minus r, a over 1 minus r. So this right here is really minus a negative. So my first term is 3, and I'm going to multiply by negative x squared. So the next one's going to be negative x squared, and my 3's would cancel. The next one would be positive x to the 4th over 3. And I'm going to do one more just to see it. Minus x squared, sorry, not x squared, x, multiply that by x squared, so x to the 6th. And then divided by 3 squared. So you can see lots of patterns. The top goes 2, 4, 6, and the 3's are going 3 on the top, none, 3 on the bottom, 3 squared. And then our general term, remember it's a r to the n. So we could write this as 3 1/3 to the n, negative 1 to the n, x to the 2n. And again, for the quiz, you do not need to simplify that. It's just something we're going to need eventually. And the last ones are going to be building it by the definition. So you remember the definition of a Taylor polynomial? It looks like f of 0, the first derivative, first power, the second derivative, the second power, the second factorial. So on this one, they asked us to do a degree 3, and we don't need to do the nth term, but they gave us what f of 0 is. So f of 0, right here, this is 2. Now they gave us a formula to find the derivative. So now that we have a way to find the derivative, what we're going to do is if I want the first derivative, we're going to plug in n equals 1. So we would get negative 1/2 times 1 factorial. So this right here is negative 1/2. If we want to find the second derivative, we're going to plug in n equals 2. So this would be positive 1 over 2 squared times 2 factorial. I'm going to do one more just to make sure that we got the patterns. The third derivative, again, we'd plug in n equals 3. So it would be 1 negative 1 over 2 cubed times 3 factorial. Okay, so let's write out the polynomial then. So f of 0 was 2. The first derivative was 1/2. The second derivative is right here, so it's plus 1 over 2 squared times 2 factorial. And remember, that's also x squared over 2 factorial. And then we do the cube. The cube here is minus 1 over 2 cubed times 3 factorial, x cubed over 3 factorial. And if you look at this, it actually simplifies very nicely. The first term is 2. The next one is 1/2 x. Then we have 1 over 2 squared x squared. The 2 factorials cancel. Then we have minus 1 over 2 cubed. Then we have x cubed. So you can see we got lots of patterns. We do have somewhat alternating, but not completely alternating. Sorry, this is negative. It is completely alternating. It looks almost geometric. I think if you got rid of the first term, it would be geometric. If I made the first term equal to 1, it would have been geometric. And the last one, I can either give you a table or anything like that, but this one's different because it's centered at 3. So remember, that would be f of 3, and then you would take the first derivative of 3, then you have to do x minus where it's centered over 1 factorial, then the second derivative at 3, x minus 3 squared over 2 factorial, and so on and so forth. So f of 3 is 1. f prime of 3 is -1. F double prime of 3 is 3. And then the last one, f triple prime of 3 is 2. So then you'll have x minus 3 cubed over 3 factorial. So that's what your quiz will look like on Thursday.